Good morning, student. Today we are going to see about LVDT, linear variable displacement transducer, bar transformer. It is a fourth unit of robotics engineering subject. Sensors for robotics. LVDT is a displacement measurement sensor for linear variable displacement. We know that we require displacement measurement for robot system for measuring the displacement for different axis positions, position measurement. Displacement also called as position measurement. LVDT, linear variable differential transducer or transformer, because it is a inductive type transducer. LVDT is an inductive type transducer. We already know that different types of transducers available are L and C, resistive, inductive and capacitive transducers. Previous classes we see that resistive transducer, that is a potentiometer, strain cages for measuring purposes, for position measurement. The same kind of position measurement, position means it is a displacement measurement, use of LVDT, it is a inductive transducer. Based on the induced EMF principle, we measure the displacement. What is LVDT? It is an electromechanical transducer coupled by any type of object or structure. It is an electromechanical transducer. Because of it is we give a electrical supply to the primary winding, the same as that of transformer action. We give supply to the primary winding. Induced electric output is produced in the secondary output. It is coupled to any type of object or structure, convert the rectilinear motion of an object into corresponding electrical signal, that is measurement of displacement. Precision of LVDT, movement as small as few millimouth of an inch. Usually measurement are taken on the order of 12 inches. Some of the LVDT capable to measure up to 20 inches. It is a construction and operating principle of LVDT. I already said LVDT is a transformer action. It is a single primary winding and two secondary winding. Secondary is the equal number of turns. We are split into two secondary winding. In transformer, based on the primary and the secondary number of turns, it is step up or step down transformer. Same the principle it used in this LVDT. We split primary winding is a single winding and the secondary winding as a two windings, S1 and S2. It is shown in this figure. In between that two secondary windings, the core is placed. That is a piston-like core is placed in between the two secondary windings. That is wound. It is in null position. The core is in null position. The two secondary windings are equal number of turns. If the core is moved either direction, forward or reverse direction, it takes both displacement, forward displacement and reverse displacement. And the core is moved based on the movement of core. The secondary winding number of turns is increased or decreased. So the difference between the secondary S1 and S2 is measured. Based on this measurement, we measure the displacement of the core. The core is directly connected with where we measure the displacement. We connected the core into that place. Based on that movement of core, we measure the displacement up to 20 inches. It consists of basically primary and two secondary winding wound over hollow tube, and position to primary winding is between two secondary. It shows in figure construction of the LVDT. The iron core slide within the tube Therefore, the magnet coupling between the primary and secondary, when core is at center, it is it split the two equal number of windings. It is the graph shows that at core is at null position, it is called a zero position. So core is moved either forward or reverse direction. The voltage output voltage is linearly variable based on the forward or reverse direction. Forward direction movement, it gives a forward positive voltages. And reverse direction, it gives a negative sign. So based on that core movement, we measure the linear displacements. Why use of LVDT? LVDT, many type of displacement transducers are available. Why we go for the LVDT means it is a friction-free operation, no mechanical contact between core and coil. Because there is no mechanical contact. If you are going for a potentiometer, they are directly connected with mechanical connection. Here it is no mechanical connection between the core and coil. Therefore, usually infinite of mechanical life. Therefore, there is no friction in this LVDT use of. Infinite resolution electromagnetic coupling limited only electrical noise. It is limited noise because of there is no friction or movement or directly coupled with any of the mechanical core directly connected with job. Low risk of damage. Most of the LVDT has a bore holes. Therefore, risk of it is wounded on the bore holes. Therefore, it is not. It is safe. Low risk damages. Null point repeatability and zero displacement can be measured. Zero displacement can be measured means it is in the core is in null position. We measure the zero. Zero is a measurement, and core is in forward direction. It is measured by the forward movement, and core is in negative direction. It is reverse direction. We measure the negative displacement. Single axis sensitivity, effect of other axes not felt on the axis of interest. Environmental result, the stable and strong sensor, good structure of engineering technology. Where we use the LVDTs, these are the different area of application. We are using the LVDT as a displacement measurement. Automation machineries, we are using the automation machineries because it gives the output as electrical voltage. So we use automation machineries. Civil structure engineering, power generation, manufacturing, metal stamping and forming, OEM, bulk and papers, industrial valves, R&D and testing, automobile ranging and robotics. These are the where whenever we need automation for displacement automation, we are going for electrical transducers. Therefore, it is very much useful for automation technologies. Use of civil structure engineering, example, displacement measurement, embedded, concentrated, tested and tensile, compression, bending, strength and crack growth in concrete, deformation and grip concrete wall used for rating wall, large gas pipe installation, dynamic measurement of pedic and large structural component used in the suspension bridge, downhole application measurement of displacement, grip and bed track. There are different types of LVDTs in market, that is DC as well as AC operated LVDT. Based on the input supply we are giving, based on the input supply, we are classified into two, DC and AC, direct current and alternative current. DC operated is a years of installation, simple and data conditioning, operate from dry cell batteries, remote location, lower system cost. Because of DC operation is very much easy, so we are going for DC. Many of the LVDTs are operated as a DC because of we need to automate we need to use in remote locations. AC operated smaller than DC, more accurate than DC, operate well high temperatures. Types of LVDT, there are based on the armature core. We classified different types of armature LVDTs. Unguided armature that fit loosely bore holes, LVDT body and armature separate mounted must ensure the alignment. Frictionless movement, suitability, short range, high speed applications, high number of cycles. If the number of cycles is high, means we go for the unguided armature vehicles. Capacitive guided armature, resisted and guided by low friction bearing assembly. Suitability, larger working range. Alignment is potential problem. Alignment is in captive guided armature. Guided armature means it is guided armature is used for alignment problem for potential problems. Spring extended armature, it is restraining and guided by low friction bearing assembly and internal spring pushes the armature to maximum extensions. Maintain reliable contact with the body to measure suitability, static and slow moving applications such as joint opening and prevent slip. These kind of spring extension armature type LVDTs are used in robotic system. This is a general types of LVDT. Centric segment. I already told that it is a piston type arrangement. Inside the piston, it is the piston like is a core, and it is placed in the system. It is unguided capacitive armature, captive armature, and spring extension armature. Based on that core movement, we classified as the armature core. That side of block source is the two windings. Spring extension armature with standard ball tips. Captive armature with spring bearing. Unguided armature with threaded tips. These are the LVDT components. This is a cross-section view of LVDT. Inside how it is there. We already see that how the secondary and primary windings are classified in circuit diagram. It is a cross-sectional view diagram. That is two primary coils, single primary coil and two secondary coils placed in the magnetic seal. It is all are sealed with holes. High density glass field coil forms signal conditioning circuitry. This signal conditioning circuitry, it is an instrumentation system. Because of we measure in terms of displacement. It gives output as electrical voltage. It is a small electrical voltage. It is converted in the signal conditioning unit, convert into the 0 to 5 volt corresponding LVDT output. These are the main components used in the LVDT system. Advantages of LVDT: the output of LVDT displacement up to 5 mm. The change in output voltage is continuous and stepless. High output, low hysteresis. The output of LVDT is up to 5 mm, plus or minus 5 mm, that is up to 10 mm. We measure the displacement as a forward and reverse direction also. The change of output voltage is continuous and stepless. High speed, high output and low hysteresis. Thank you. In this class we see about the LVDT, that is linear variable differential transformer. Next class we see about RVDT, rotary variable differential transformer. Thank you.